Because um, today we'll be taking based on request, but someone has requested we tackle this question from PM for May 2023 question 5. So we'll be preferring a solution to this. It has to do with investment appraisal, the one with expected value and joint probability. So we'll take the question, from there we'll provide a solution to the question in as much detail as possible to make it very much understandable and clear. Thank you.
A company is considering whether or not to invest in any of the two projects, where the initial cash investments will be 13 million naira for A and 14 million naira for B. The projects would have a 5-year life, and the estimated annual cash flows are as follows. Project A, all figures assumed to be correct. Project B, all figures assumed to be correct. The company cost of capital is 10%. The estimates of cash outflows are considered fairly reliable. However, the estimate of cash inflows are much uncertain. Several factors could make the annual cash flows higher or lower than expected. Factor 1. There is a 20% probability that government measures to control the industry will reduce annual cash inflows by 25%. Factor 2. There is a 30% probability that another competitor will also enter the market. This would reduce the estimated cash inflows by 10%. Factor 3. There is a 40% probability that demand will be stronger than expected. The company will not be able to supply more products to the market, but it would be able to sell at higher prices, and cash inflows will be 5% higher than expected. Required: A. Calculated the expected net present value of the two projects. B. Which of the projects will be more profitable?
Alright, let's provide a solution to the question. They gave us some things. They say the outflows of the firm is very much certain. But there are some things that will affect the inflows of the firm. They gave us 3 factors that might happen that will affect the inflows of the firm. They said factor 1, there is a 20% chance that government measure to control the industry will reduce annual cash inflows by 25%. That is a negative, minus 25, when we are taking note of such effect. Reduce. Factor 2, there is a 30% probability that another competitor will also enter the market. This would reduce, that is also a negative. This will reduce the estimated cash inflows by 10%. Then factor 3, there is a 40% probability that demand will be stronger than expected. The company would not be able to supply more products to the market, but it would be able to sell at higher prices, and cash inflows will be 5% higher than estimated. So we are going to put all of this into consideration. We will consider the computation of the joint probability. To consider the computation of the joint probability, we'll have, let's see, serial number. Or we'll just analyze the outcomes, then later on we'll start taking this. Now, the chances of any of those factors playing out, we take them all. There is a chance that all the factors, there is a chance that all the factors will play out, all factors occur. There is a chance that all the factors occur. There is a chance that none of the factors occur. There is a chance that none of the factors occur. There is a chance that factor 1 and factor 2 will occur. There is equally a chance that factor 1 and factor 3 will occur. There is also a chance that factor 2 and factor 3 will occur. So we have all factors will occur, none of the factors will occur. Factor 1 and 2, factor 1 and 3, factor 2 and 3. Those are combinations. There is also a chance that only factor 1, only factor 1 will occur. There is a chance that only factor 2 will occur. There is also a chance that only factor 3 will occur. So here, these are the possible outcomes. All factors will occur, none of the factors will occur. F1 and F2, which is factor 1 and 2 will occur. Factor 1 and 3 will occur. Factor 2 and 3 will occur. Those are chances. Only factor 1, only factor 2, and only factor 3. So these are how many outcomes? 1, 2, 3, 4, 5, 6, 7, 8 outcomes that is possible. So I have 1, 2, 3, 4, 5, 6, 7. Possibility of 8 outcomes coming out. So each of these factors we'll consider as factor 1. We'll bring in factor 2. Also bring in factor 3. The probability that all factors will occur will indicate with yes. Probability that it will occur, yes. Probability that it will not occur, we say no. So we can say probability of occurrence will indicate as yes. Probability of no occurrence will indicate as no. So we're doing that with yes and no. So the probability that all factors will occur will come out as yes, yes, and yes. So all factors occur. Probability that none of the factors, so no factor will occur, will come in as no, no, no. None of them turning out. Then probability that factor 1 and factor 2 will occur will give us yes, yes, then no factor 3 there. So this is 1 and 2. Probability that factor 1 and 3 will occur will be yes, yes, and no. Probability that factor 2 and 3 will occur will be no, yes, and yes. 2 and 3. Then there is a probability that only factor 1 will occur. So that will be yes, no, no. We have probability that only factor 2 will occur. That will be no, yes, no. Probability that only factor 3 will occur will be no, no, and yes. So these are our indications. Then we are going to multiply each of those probability or chance to get what we call joint probability. So we'll multiply that. Multiply to get joint probability. So I have multiplication of outcomes. Multiplication of outcomes. Then we equally have joint probability, which I will indicate as JP. So the multiplication of outcomes, the chance that all will occur, which we say is yes, 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 we are going to pick the probability attached to each of those factors given in the equation. For the probability that factor 1 will occur, there's a 20% chance. Probability that factor 2 is 30%. Probability that factor 3 is 40%. So I will do 0.2 times 0.3 times 0.4. That will be 0.2 times 0.3 times 0.4. The probability that 3 of them will occur. That will be 0.2 times 0.3 times 0.4, which we'll have as 0.2 times 0.3 times 0.4, giving us 0.024. 0.024. That is the joint probability of all three happening. Then we'll look at the probability of none happening. If you say no, 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 meaning none of them will happen. If there is a 20% chance that factor 1 will happen. Then there is an 80% chance that it will not happen. If there is 30% chance that factor 2 will happen, then there is 70% chance that factor 2 will not happen. If there is 40% chance that factor 3 will happen, then there is 60% chance that factor 3 will not happen. So the opposite of what you have here. So that will be 0.8 times 0.7 times 0.6. 0.8 times 0.7 times 0.6, giving us 0.336. So 0.336. That is our probability that none will occur. Then we have yes, yes, no. So there is 20% chance factor 1 will occur. 20%, 0.2. There is 30% chance factor 2 will occur. Then let's say factor 3 will not occur. So we'll use the 60% chance. 0.6. So that will be 0.2 times 0.3 times 0.6. 0.2 times 0.3 times 0.6, which gives us 0.036. So 0.036. Then here we see there is a chance that factor 1 will occur, which is 0.2. There is no chance that factor 2 will occur, so that will be the remaining 0.7, because the factor that says it will occur is 0.3, the remaining is 0.7. Then we'll pick the 0.4 for this one, since they said it will occur. So 0.4. So we'll have 0.2 times 0.7. 0.2 times 0.7 times 0.4, which is 0.056. So 0.056. Then we only have the probability that F1 will not occur, which is 0.8. F2 and 3 will occur, so I will have 0.3 times 0.4. So I have 0.8 times 0.3 times 0.4. 0.8 times 0.3 times 0.4, which gives me 0.096. 0.096. 0.096. Also, we have probability that F1 will occur, which is 0.2. No chance of 2 and 3 happening, so I'll have 0.7 times 0.6. So 0.2 times 0.7 times 0.6. 0.2 times 0.7 times 0.6 gives me 0.084. 0.084. Then the probability that F1 will not occur is 0.8. Probability that F2 will occur is 0.3. The probability that F3 will not occur is 0.6. So I have 0.8 times 0.3 times 0.6. 0.8 times 0.3 times 0.6. That will be 0.144. 0.144. Then the probability that F1 and F2 will not occur is 0.8 times 0.7. Then they say F3 will occur, which is 0.4. So 0.8 times 0.7 times 0.4. 0.8 times 0.7 times 0.4. So that should give us 0.224. 0.224. If all is added together, you always arrive at 1. So you can see also verify that. It gives us 1. This is the total. Then we have succeeded in computing the joint probability, and we are going to proceed from there to check the effect of this joint probability on the inflows we are going to have. After computing that, they will proceed to computing the net present value for each of the projects. Remember, they say it will only affect the inflows. and will not affect the outflows. So I'll proceed to compute the impact of the joint probability So the impact of the joint probability impact on cash inflows. So for the computation of the impact on cash inflows, I'll still have the 8 outcomes as I listed before. So I have the 8 outcomes. I have 1, 2, 3, 4, 5, 6, 7, and 8. Then I'll take the joint probability as we have gotten. Joint probability. Our joint probability, the first was 0.024. 0.024. The second is 0.336. 0.336. The third we got was 0.036. 0.036. We had 0.056. 0.056. We had 0.096. 0.096. We also had 0.084. 0.084. Then we had 0.144. 0.144. Then we had 0.224. 0.224. So these were the joint probability we had from our first computation. We'll check the impact on the inflow. So I'll take it in this way. Impact on inflow. I will say result. Then finally I'll say expected value. Expected value. So we'll proceed. The impact on the inflow. The first one they said that all three will occur. All three will occur. If all three will occur, what will happen? If all three will occur, all these factors they gave here in the question, they said there is a 20% probability that government measures to control the industry will influence annual cash inflows by 25%. That is, it will reduce the annual cash inflows by 25%. The other one, there is a reduction of 10%. Then lastly, there is an increase of 5%. So I will take note of those effects. So I have 1, which is the total of the probability, minus, if factor 1 occurs, I will have a reduction. I will have a reduction of 25%. So minus 0.25. If factor 2 occurs, I will have a reduction of 10%. So minus 0.10. If factor 3 occurs, I will have an addition, that is an increase of 5%, 0.05, so plus 0.05. So 1 minus 0.25 minus 0.10 plus 0.05 will give me, I have 1 minus 0.25 minus 0.10 plus 0.05 will give me 0.7. So that is 0.70. Now, to get my expected value, I'll have 0.024, which is the joint probability, times the result we have, which is 0.70. So that would give 0.024 times 0.70 will give us 0.0168. 0.0168. So 0.0168. That is my expected value for outcome 1. We'll go to outcome 2. Outcome 2, they say the probability that none will happen. So each of those 3 factors, none will happen. I will have 1 minus none will happen, none will happen, none will happen. So we'll have 1 minus 0 minus 0 minus 0, so it can still be effectively 1. So that will be still 1, no impact. Then here will be 0.336 times 1, which will still give us 0.336. So that is for outcome 2. Outcome 3, they said 1 and 2 will occur. 1 and 2 will occur. And for 1, if factor 1 occurs, there will be a reduction by 25%, which is what I have here. And if factor 2 occurs, there will be a reduction by 10%. So those are the only two that will come in. So I have, if factor 1 and 2 occurs, I will have 0.25. I also have minus 0.10. So those are the only ones effect we are going to have there. So that will be 1 minus 0.25 minus 0.10, which will give us 0.65. So here I have 0.65. So 0.65, to get the expected value, will be 0.036 times 0.65. That will give me the expected value. 0.65 times 0.036. That will give me 0.0234. 0.0234. 0.0234. Now, we'll go to the outcome 4. Outcome 4 is for factor 1 and factor 3 occurring. Factor 1 and factor 3 occurring. That is factor 1 occurring and factor 3 occurring. So here I will have 1 minus 0.25 plus 0.05. So factor 1 and factor 3 occurring. So what I will have there is 1 minus 0.25 plus 0.05. That will give me 0.85. 0.85. Now the expected value will be 0.056 times 0.85. 0.056 times 0.85. So I'll have 0.85 times 0.056, which will give me 0.0476. 0.0476. 0.0476. Okay, let me recheck this. I think I have it. 1 minus 0.25 will give me 0.75 plus 0.05. I think there is a calculation error here. This is 0.80. This minus this will give us 0.75 plus this will give us 0.80. The calculation error. 0.80. So 0.80 times 0.056. That will give us 0.0448. 0.0448. Okay. So 0.0448, the fifth outcome, we have a probability of 2 and 3 occurring. So factor 2 and factor 3 occurring. The chance that factor 2 and factor 3 will occur. So that will be 1 minus the factor 2 is 0.10 and factor 3 is plus 0.05. So let's get that. That will be 1 minus 0.10 minus 0.0, okay, plus 0.05. That gives us 0.95. 0.95. So 0.95 to get the expected value will be 0.096 times 0.95. That will give us the expected value. So 0.95 times 0.096. That will give us 0.0912. 0.0912. That is my expected value. Then for outcome 6 is only factor 1 occurring. Only factor 1 occurring. So I have 1 minus my factor 1 is 0.25. So that is the only thing. Since it's only factor 1, then that will give us 0.75. I think I should treat this at once. 1 minus only factor 2. Only factor 2 is this. 1 minus 0.10. Only factor 3 is 1 minus 0. Okay, that is plus factor 3. 1 plus 0.05. So those are, let's get these ones at once. Okay, 0.75 times 0.084. That gives me 0.063. So that will be 0.084 times 0.75. 0.063. 63. Okay, 0.063. We'll proceed to these other last two. That will be 1 minus 0.10, which is giving us 0.90. 0.90. So this would be 0.144 times 0.90. 0.144 times 0.90. 0.144. That gives us 0.1296. 0.1296. 0.1296. Then lastly, this one is an addition. So 1 plus this will give us 1.05. So this will be 0.224 times 1.05. 0.224. 0.224 times 1.05 gives us 0.2352. 0.2352. 0.2352. 0.2352. And the addition of it all, sort of wasting much time, the addition of it all, we have this plus this plus this plus this, and the rest will give us the total expected value. And our total expected value is 0.94. So we have 0.94. We can still recompute to verify all figures. You can recompute to verify in case there is any computation error in adding up this, but you have 0.94. So that 0.94 we have, we proceed with this expected value to compute net present value for both project A and project B. We'll start with the project A. As they clearly told us that our discount factor is 10% and that whatever factors that are given here does not affect our inflow, does not affect our outflow. Our outflow is reliable, it only affects our inflow. So this our expected value, 0.94, will only be affecting our inflow values that have been given here already. So we'll compute for project A, then we'll go to project B. So let's do project A and project B. So project A. Now, project A, we have series of cash inflows provided here, and we have the cash outflows as well. But here they said the company is considering whether or not to invest in any of the two projects where the initial cash investment will be 13 million naira for project A. That is an outflow. So let me consider I have here 0, 1, 2, 3, 4, and 5. The 5 years project. Then the cash inflow, the inflows provided in the equation. The inflows provided in the equation, they have 6 million. I think I'll just use this so that I'll just use 6,000. So 6,000 is 6 million, is in millions. I have 8 million. Alright, 6,000. I have 10 million. I'll say right as 10,000 because of this. I have 9 and finally 6. 9 then 6. Okay, these are the inflows provided by the equation, but we need to adjust them with that 0.94 expected value. So I will have expected inflow. Expected inflow is simply 6,000 times 0.94. We have 8,000 times 0.94. This is in millions. We have 10,000 times 0.94. We have 9,000 times 0.94. We have 6,000 times 0.94. So that will give us our expected inflows. Okay, so our expected inflows, we have 6,000 times 0.94, which gives us 5,640. So 5,640. This will also give us 5,640. This is the same 6,000. So 8,000 times 0.94 will give us 7,520. 7,520. We have 10,000 times 0.94. That should give us 9,004. So we have 9,000 times 0.94. It gives us 8,460. So 8,460. These are the expected inflows. Now, we'll less the outflows. We'll less the outflows to get the net cash flow. Then we'll apply the discount factor, and finally we'll get the present value. The outflows, remember, are in millions too. The outflows provided is 3 million. Let me put that in millions. The initial outlay for project A is 13 million. So I'll bring it in here as 13 in bracket. 13. The first year is 3 million. 3 million. The second year is 4 million. Third year is also 4 million. 4. The fourth year 3 million, then fifth year 3 million. So 3 and 3. If I less these values, I will have the net cash flow. So here this will still remain 13. The DCF is at 10%, remember. So 5,640 minus 3 will give us 2,640. 7,520 minus 4 will give us 3,520. 94 minus 4 will be 54. 8460 minus 3 will be 5460. 5640 minus 3 will be 2640. So we have as our net cash flow. Our discount factor at 10%. Our discount factor at 10%. We have 10 over 100 plus 1 divided by 1.1. Our first year is always going to be 1. Our second year is 0.909. Our third year, our first year is already 0.901. Second year is 0.826. 0.826. Third year 0.751. 0.751. Next we have 0.683. 0.683. The next 0.620. 0.620. So if we multiply this, we'll have our present value. So this multiplied by each of these values. So that will be 1 times this, to still give us negative 13. 2640 times 0.909 will give us 2399.76. 2399.8 approximately. 2399.8 approximately. Then we have 3520 times 0.826 give us 2907.5. 2907.5. 2907.5. Okay. Then next we have 54 times 0.751. 4055.4. 4055.4. 4055.4. E4 5460 times 0.683 to give us 3729.2. 3729.2. 3729.2. Then the last one, we have 2640 times 0.620. That will give us 1636.8. 1636.8. 1636.8. Last year discount factor, that was 0.7. You are supposed to approximate this by 1. Sorry. I will check that value. That is 10 divided by 100 plus 1 divided by 1.1. Okay, 0.6209. That should be 1. That should be 2640 times 0.621. That gives us 1639.4. 1639.4. 1639.4. Then we'll get the net present value for A. Net present value for A. We have 1639.4 plus 3729.8 29.2 plus 4055.4 plus 2907.5 plus 2399.8 gives us 14731.3 minus 13. That gives us 1731.3. 1731.3. 1731.3. Remember, this is in millions, so the same thing. MPV for A is therefore 1,731,300. So that is the net present value for project A. We go through the same process for the net present value of project B. So we proceed to get the net present value of project B. Project B net present value. Then we'll compare the two. Project B net present value. Recall what we got. We said we had 1,731,300. That was for project A. So we can easily compare. Now I'll take project B. Project B. Project B, the cash inflows as provided in the equation. The cash inflows will have a 10 million. Here for 10,000 because of this. I have 988. The next one is also 8. The next one will have 4. So these are the inflows before we adjust. So to adjust, I have 10 times 0.94. 9 times 0.94. 8 times 0.94. 8 times 0.94. 4 times 0.94. So that will give us the expected inflows. So I think we've done that first one before, and we've had 9,400. The second we have done before, I don't think I can recall. 9,000 times 0.94, that is 8,460. 8,460. We've equally done the one for 8,000 before, but let's 8,000 times 0.94. That will give us 7,520. 7,520. 7,520. Then 4,000 times 4,000 times 0.94 will give us 3,760. 3,760. Then the outflows. The outflows, I said the initial outlay of project B is 14 million. So for outflows for project B, we have the initial outlay as 14 million. First year cash flow given here is 5. We have 5 million. The next is 4 million. So we have 5. We have 4. Followed by 3, 3, and 2. 3, 3, and 2. Okay, this will still give us 14. This will give us 4,400. This will give us 4,460. This will give us 4,520. This will give us still 4,520. And this will give us 1,760. Okay, the DCF at 10%, to recall, we had one here. Here we have 0.909, 0.826, 0.751, as much as I can recall. We also have 0.683, 0.683, 0.621. So those are the discount factors. So we'll multiply. This would also give us 14. Then 4,004, 44 times 0.909 will give us 3999.6. 3999.6. Put it that way. The next, we have 4,460 times 0.826. 0.826. That will give us 3683.96. 3683.96. 3683.96. So we'll have 4,520 times 0.751. That will give us 3394.52. 3394.52. 3394.52. Then we'll have 4,520 times 0.683. 3087.16. 3087.16. 3087.16. Then 1760 times 0.621. 1092.96. 1092.96. 1092.96. So we get the net present value for B. The net present value for project B, 196 plus 3087.16 plus 3394.52 plus 3683.96 plus 3999.6 minus 14. 1258.2. 1258.2. 1258.2. So NPV of B is 1,258,200, which is obviously lesser than the net present value will go for A, which is 1,731,300. And the B part of the equation was asking us, they said, which of the projects will be more profitable? So we will just advise them. The B part can say project A will be more profitable because it has a higher net present value than project B. So that is that, and that is the requirement of the question. I hope you find the video useful in your preparation for performance management Ican examinations for November 2025. Thank you very much for your time.